We're doing the data analysis of avocado prices for Project 2. I'm Julia Chen. We have Samantha Fowler, Luye Liu, and Zhihao Tang. In this notebook, we'll be analyzing the historical data of avocado prices and sales volume in multiple U.S. markets while incorporating time series data. Now we have some previously used code from Project 1, and that has been labeled in red italics, signifying the start and the end of our old code. So in our table of contents, we'll first be cleaning and modifying the data and kind of showing you guys how we did that. We'll then be going through the descriptive statistics, so how can the data be modeled, and how have avocado prices changed over time. Lastly, we'll be going through the conclusion with some limitations on our data and future questions that we have regarding avocado prices in general. In order to be consistent with our last project, we'll start with some old code to clean and modify the original data set in order for us to perform some further analysis based on our previous work. So first, in cleaning and modifying the data, we imported the necessary modules such as pandas, numpy, skippy, statistics, and matplotlib. And now we'll be viewing our data frame. First, we viewed the first 5 and the last 5 rows just to see that our data was read correctly, which as you can see it was. We then put the numerical columns of the avocado data and performed basic statistics on them, such as the mean and the average. So we found that the mean average price, or typical price of avocados, is 1.41, and the spread is from 0.44 to 3.25. We found that the median price is 1.37. Another factor to point out is that we also calculated the weighted mean. We found that the weighted mean and the mean was exactly the same, showing that our data has little error and is precise. We then proceeded with our data. We need to add and kind of manipulate our data so we could go through with our time series. One useful value that should be analyzed is if the month affects the average price and if it affects the total volume of avocados. However, the data frame only has a column called date, which includes the year, month, and date. We then created a new column called month, and we copied all the data in the data column to the month column so we can remove the unwanted parts. And then finally, we used the string indexing inside a lambda function to remove the first 5 and last 3 characters. And now we have a column called month. We then went through to find the average price, and we saw that the average price of each month. October has the highest mean price of 1.58, and February has the lowest mean average price at 1.27. We then used the pivot table to compare numerical data to certain factors. In order to work with the time series part of our data, we then changed the column data to the type data frame, and then we also created a date and time index. I'll now be handing it off to Sam to talk about descriptive statistics.
All right, so to begin with the descriptive statistics, we wanted to look at how our data could be modeled. So here we can look at the best fit line with the dependent variable being the average price and the independent variable as the month. And as you can see, our regression line is average price equals 0.02 times month plus 1.292. So we can also create a visual summary of this data, which is seen below, which also shows that the R is equal to 0.162, showing very little positive correlation between the average price and the month. So below, we compute and plot linear models for the average price and year distinguished by type. Here on the left, we have conventional, and here on the right, we have organic. The organic avocados are shown to be priced higher and is not dependent on year. We can look further and use the Seaborn module to make a scatter plot of the data that is colored by year. And in addition, we used the Seaborn to create a regression line so we can see the differences. Below, we use total volume as the x-axis and y as the average price. The linear regression shows that as total volume increases, average price decreases. Here we do the same thing, except we use conventional and organic. And as you can see, organic prices are not only higher as expected, but have a wider range of prices and are consistently at a small volume. And the volume does not seem to have as big of an impact on the price for the conventional avocados. So next we create a pivot table using the average price with index as year and the column is the month. And we use this pivot table to create a heat map. And as you can see, the results show that the prices were highest in the fall of 2017 are generally lower in the winter months from December to March and April. Next, we use our time series data to plot the average price. Here you can see from 2015 to 2018 the average price, and then here in 2017 there's a slight increase. And just to support the conclusions from our heat map, we plotted the 2015 average price, which also shows an increase from around July to October in average avocado price. Next, we created rolling statistics to smooth over the data. And first, we computed a rolling statistic using 2 weeks as our window, and the graph consists of the data, the mean, median, and standard deviation for 2017. We also created another rolling statistic to show the weekly, 7-week, and 28-week mean moving average for 2015 to 2017. As you can see, in blue is weekly, and in green is 7 weeks, and in red is the 28 weeks moving average. We also use seasonal decomposition to help us destruct the time series. Here's plots to show the comparison of the trend, seasonal, and residual graphs. We can look further into detail here with our data being in blue and our trend in red. As you can see, the trend shows a slight increase in prices as time goes on. The seasonal graph is very important as well, showing the spikes around October every year. Here we have a seasonal for 2017, and furthermore we provide a graph of the residuals. We'll be moving on to the ARMA plots.
So I'm going to briefly introduce what the ARMA model is. So the ARMA model, we can divide it into two models, which is the AR model and MA models. So the AR model means the YT depends on the past value, and MA model means YT depends on the random arrow turn. So the ARMA model means this model combined together, so we can use this model to forecast what our data statistic will look like. So this is the autocorrelation and partial correlation plot. So this is the ARMA model results. There are two plots here, and this is the avocado price residual. We can see there are lots of peaks in the fall, and we can also include QQ plot. We can see from the plot there are deviation at both ends, which is not a good result. So we can create another autocorrelation plot. And this is the autocorrelation plot. This is the partial correlation plot. I will pass it to next.
Thank you. So next, we want to do a kernel density estimation to visualizing the distribution of avocado price. First, we will simply plot the KDE for our average avocado price variable. Second, we will construct the two-dimensional kernel density estimation between date and average avocado price. There's a various way to construct the KDE. In the following code cell, we use the sklearn module to plot the one-dimensional kernel density estimation for the average avocado price. Next, we first convert our time data to some numerical data that can be visualized along this axis. Then we plot a simple KDE for the time data as well. Next, we will have the joint distribution between average price and modified date using the Seaborn module. Also, there's a one-dimensional KDE graph on the top and right side of the graph. Next, I'll pass on to Julia to conclude for our project.
Thanks for looking at all of our statistics. After running through all of our statistics and graphing and analyzing our data, we found out a lot of things about avocado prices and regions. As we mentioned before, when calculating descriptive measures, we found that the mean price of an avocado is $1.4 and the median price is $1.37. We calculated the weighted mean and found that the mean and weighted mean is exactly the same, showing that our data had little error and is very precise. Moving on with our data, we analyzed whether that the month of the year affects the average price and the total volume of avocados. After we grouped the prices by month and average price, we found that October has the highest mean price of 1.58 and February has the lowest mean average price of the 1.27. We found that the best fit line was y equals 0.02x plus 1.292 and the Pearson-R correlation was 0.162. When we created a visual summary of the data, we found that there was very little positive correlation between average price and month, and after we plotted the linear model for the average price and year, we distinguished by type and we found that organic avocados are shown to be priced higher and is not dependent on year, while the conventional prices seem to increase through time and the correlation is not strong. We then created a seaborne plot and showed that as total volume increased, average price decreased, which is parallel to usual supply and demand theory. As we changed attribute to type, we see differences between organic and conventional avocados, and we found that organic prices are higher than expected and they have a wide range of prices that are consistently at a small volume. This shows that volume does not seem to have as big of an impact on the price for organic than it does for conventional. We then created an auto-regressive moving average model to forecast the data and then proceeded to plot the model residuals. As we saw in earlier results, prices spiked at the end of the year, so December and January, and dropped in February. In order to determine whether the model fits the dataset, we introduced the QQ plot. We found that the plot deviations occur at both ends of the graph, which is not a good result. We then created autocorrelation plots to further visually see the data. In the end, we used kernel density estimation to visualize the data distribution of avocado average prices and a two-dimensional density estimation between average price and data. Now, there were some limitations on our data, and because the data from 2018 is incomplete and certain months have not occurred yet, the data could be skewed. We're also only looking at prices from America and not other countries. We did not look at how import prices could affect the prices of the avocados. For future questions, we could look at the demand of avocados in all of North America and how each country's prices compare to each other, such as Mexico and Canada. We could also look at demographics of who is buying avocados and at what price. And one last question could also be looking at the prices of avocados at different retailers and how each retailer affected the price of avocados. Thank you.